Hi, in this video, we are going to look at how we go about solving simple simultaneous equations. Now, in previous sections, we have been given one equation and asked to solve for the unknown variable. Now, we will use two equations to find the values of two unknown variables. Remember that the value of each variable is the same in each equation. So, the value of x in equation 1 will have the same value as equation 2, and this applies to the variable y as well, or whatever variables that you are working with. There are three methods you can use when working with simultaneous equations: substitution, elimination, and graphical. The graphical method is only used in geometry, so you will find our videos using the graphical method in the geometry section. We will focus on substitution, as you can use this method to solve any simultaneous equation. To better explain how we go about tackling simultaneous equations, let's look at some examples. Solve for x and y using the following simultaneous equations. Y minus 3x is equal to 0, and x plus y is equal to 8. The aim here is to find the values of x and y that make both equations true. I like to write my equations on each side of the page. So let's put y minus 3x on the left and x plus y on the right. And now we can solve. The first step is to find an equation that contains a variable without a coefficient. Here we have a y, here we have an x, and here we have a y. So I'm going to use this equation over here, y minus 3x. Let's make y the subject of this equation. So I can say y is equal to, let's move the negative 3x across, and we get this equal to 3x. If you are not sure of how to do this, please go and watch our videos on literal equations. The next step is to substitute this value over here into the corresponding value of the other equation. We've just said that y is equal to 3x. So on this side, we're going to say x plus, instead of writing y, we can write 3x, and we make this equal to 8. Now we have a linear equation, x plus 3x is equal to 8, and we can solve for the remaining unknown variable. Let's do this now. X plus 3x gives us 4x, which is equal to 8. Divide both sides by 4, and we see that x is equal to 2. Now we can substitute this value back into the corresponding variable in our first equation. We see that x is equal to 2. So on this side, we can say y is equal to 3 multiplied by 2. And finally, we can solve for y. And we see that y is equal to 3 multiplied by 2, which is 6. Let's make some more space and look at some more examples. Here we have x minus y is equal to 4 and x plus y is equal to 6. None of these terms have got coefficients, so I'm going to use this x over here and make it the subject of this equation. So we say x is equal to, I have 4 on the side, let's put 4 over there, and we're going to move the negative y and make it positive y. Now that I've got 4 plus y, I'm going to substitute it into the x value over here. So I say 4 plus y is equal to 6. And now I can solve. On the left-hand side, I've got y plus y, which is 2y, is equal to 6. And I'm going to move this 4 across, so I say minus 4. Now I have 2y is equal to 6 minus 4 is 2. Divide both sides by 2, and I see that y is equal to 1. Now that I have a value for y, I can substitute it in this side. And I see that x is equal to 4 plus 1. So we find that x is equal to 5. Let's do another example. Here we have y is equal to 2x plus 1. And on this side, x plus 2y plus 3 is equal to 0. Now in our first equation, y is already the subject. So we can leave this as it is. And now I can substitute 2x plus 1 into our y value on this side. So I'm going to have x plus 2. Instead of y, I'm going to write 2x plus 1. Close the bracket. Plus 3 is equal to 0. And now I can expand the bracket. So we have x. 2 multiplied by 2x is 4x. 2 multiplied by 1 is 2. Then we plus 3. And we make this equal to 0. Now I can add my like terms. I have x plus 4x, which gives me 5x. 2 plus 3 is 5. So I say plus 5 is equal to 0. To solve for x, let's move this 5 across. So we're going to leave 5x where it is. Make it equal to. Move this 5 and we get negative 5. Divide both sides by 5 and we see that x is equal to negative 1. Now that I have a value for x, I can substitute it into the x value up here. So I'm going to say y is equal to 2 multiplied by negative 1 plus 1. 2 multiplied by negative 1 is negative 2. So I can say y is equal to negative 2 plus 1, which means that y is equal to negative 1 as well. Let's do another one. 2x plus 3y is equal to 12, and x plus 2y is equal to 6. The only variable without a coefficient is this x over here. So let's make this the subject of this equation. And I'm going to say x is equal to the 6 that is already there. We're going to move positive 2y. So we say minus 2y. Now that we have a value for x, we're going to substitute into the x on this side. So I can say 2, open my bracket, 6 minus 2y, plus 3y is equal to 12. Now I can expand. 2 multiplied by 6 is 12. 2 multiplied by negative 2y is negative 4y. Then we have plus 3y, and it's equal to 12. Now I can add my like terms. Negative 4y plus 3y gives me negative y. I have positive 12 here, and it's equal to 12. But I want y to be positive, so we're going to move it to the right-hand side of the equation. So we're going to say y over here. Then we've got 12. Move this 12, so we say minus 12. 12 minus 12 is 0. And this is our value of y. And now I can substitute 0 into our y value over here. So I can say x is equal to 6 minus 2, which is multiplied by 0. And we know that anything multiplied by 0 is 0. And 6 minus 0 is simply 6. And this is our value of x. Let's do another example. 2x plus 3y is equal to 12, and x minus y minus 1 is equal to 0. X is the only term without a coefficient, so I'm going to make it the subject of this equation. So I put in my equal sign. Then we move negative y across, we get positive y. Move negative 1, and we get positive 1. Now we can substitute y plus 1 into our x value on this side. And I'm going to say 2, open bracket, y plus 1, plus 3y is equal to 12. Let's expand the brackets. 2 multiplied by y is 2y. 2 multiplied by 1 is positive 2. Then we have plus 3y, and this is equal to 12. Now I can add my like terms. 2y plus 3y is 5y. I'm going to move this 2 across. 12 minus 2 gives us 10. Divide both sides by 5, and we see that y is equal to 2. Now I can substitute 2 into the y value over here. So I can say x is equal to 2 plus 1, which means that x is equal to 3. Let's do one final example. 2x plus y is equal to negative 14, and y is equal to 6. Now, a lot of students have a look at this and say, well, y is equal to 6. What am I supposed to do with this? The question has already given you half of your answer. Y is equal to 6. So all we have to do now is solve for x. So let's substitute 6 into our y value over here. So we can say 2x plus 6 is equal to negative 14. Let's leave 2x where it is. Make it equal to negative 14. Move the 6 across, and we say minus 6. Now we can see we've got 2x on this side is equal to negative 14 minus 6 is negative 20. Let's divide both sides by 2, and we see that x is equal to negative 10. And we have now completed this question. You will find more examples like these in our upcoming videos.